Hello, welcome to my first video in the series on recursion. Today we are going to explore the basics of recursion, a powerful concept in programming that allows a function to solve a problem by calling itself. So what is recursion? In programming, recursion happens when a function calls itself either directly or indirectly during its execution. This enables us to break down complex problems into smaller, more manageable subproblems, often leading to elegant and efficient solutions. Recursion is especially common in algorithms that deal with repetitive or nested patterns, such as traversing data structures, solving puzzles like the Tower of Hanoi, or working with fractals. These problems are often best tackled by recursion due to their self-repeating nature at smaller scales. To solve a problem using recursion, you need two parts, a base case and a recursive case. The base case is the condition that stops the recursion. The recursive case is where the function continues to call itself, but with a smaller or simpler input, moving the problem closer to the base case with each call. Let's start by understanding recursion with an example, calculating the factorial of a number. To check if recursion works, begin by trying the problem with a smaller number. For instance, we can start by calculating 5 factorial. Now when considering recursion, ask yourself, can I break this problem down into a smaller, simpler problem? If yes, then recursion can be applied. In this case, we know 5 factorial is equal to 5 times 4 factorial. So we can reduce the problem to calculating 4 factorial and continue until we reach the simplest case 1 factorial. The general formula for a factorial is n factorial is equal to n times n minus 1 factorial. Here the problem reduces to the same form but with a smaller input n minus 1. Therefore, if we have a function to calculate n factorial, we can reuse that same function to calculate n minus 1 factorial recursively. However, for recursion to work, we also need to define a base case, the point where the function stops calling itself. For factorials, the base case occurs when n is reduced to 0. Since 0 factorial is defined as 1, we return 1 to stop the recursion. Without this base case, the function would continue indefinitely. So the base case for factorial is when n is equal to 0, at which point the function returns 1. In Python, the typical way to define a recursive function is by using a conditional statement to check for the base case. If the base case is met, the function stops calling itself and returns a value. Otherwise, it calls itself recursively with a smaller input. For example, if n is equal to 0, we return 1, which is the base case. Otherwise, we execute the recursive case by returning n times factorial of n minus 1. Let's see this in action using the PyCharm IDE. Here we have defined a function to calculate the factorial of a number. Let's write the conditional statement to calculate the base case and the recursive case. If n is equal to 0, we write the base case, else we write the recursive case. In the base case, when n is equal to 0, we return 1. Whereas in the recursive case, we return n times, we call the factorial function again, passing a reduced input n minus 1. Now here we are calling the factorial function passing a number 5 to calculate the factorial of 5. Let's run the program. As expected, we get 120 as the output. Let's take a simpler case of factorial 3 and see the step-by-step calculation. The function factorial 3 checks if n is 0. It's not, so it proceeds to return 3 times factorial 2. Next, factorial 2 is called. It also checks if n is 0, then returns 2 times factorial 1. Then factorial 1 is called, which returns 1 times factorial 0. Finally, factorial 0 hits the base case and returns 1. So the computation would be 3 times 2 times 1 times 1, which is equal to 6. Each recursive call reduces the problem size, eventually reaching the base case and unwinding the recursion to produce the final result. To better understand how recursion works, let's visualize the call stack. Each time the function calls itself, a new frame is added to the call stack. This stack keeps track of all the active function calls. When the base case is reached, the function stops calling itself and the call stack begins to unwind. Each function call returns its result and the solution is gradually pieced together as the results flow back up through the chain of calls. This visualization helps us clearly see how the problem is broken down step by step and then reassembled into the final solution. One of the most crucial aspects of recursion is the base case. Without a base case, the function would continue calling itself indefinitely, leading to an infinite loop. For example, if we forgot to include the base case in our factorial function, Python would eventually raise a recursion error because of a stack overflow. This happens because each function call consumes memory and without stopping, the stack would exceed its limit. Let's remove the base case from our factorial function and call the program again. As expected, Python throws a recursion error. Since we don't have a base case anymore, the factorial function calls itself indefinitely, which eventually leads to a recursion error. By default, Python's maximum recursion depth is set to 1000. Let's see how we can apply recursion to find the sum of the first n natural numbers. We'll start with a simple case, finding the sum of the first 5 natural numbers. So sum of 5 is equal to 1 plus 2 plus 3 plus 4 plus 5. If we reduce the input to 4, we can still use the same function to find the sum of the first 4 natural numbers. This matches the recursive pattern we are looking for. So the recursive case can be written as n plus some numbers of n minus 1. Let's next identify the base case. It can be either 1 or 0. If we choose 1, we compute the sum of numbers starting from 1. However, it's more common in recursion to reduce the problem to the smallest possible subproblem. The smallest sum is an empty sum which conceptually equals 0. Therefore, the base case is typically when n is equal to 0, meaning no numbers to sum, which results in a sum of 0. Let's run this function in Python. Here we have defined a function to calculate the sum of the first n natural numbers. As earlier, we have n equal to 0 to declare the base case where we are returning 0. Otherwise, we have a recursive case where we are returning n plus, we are calling the function again, passing a reduced input n minus 1. When we run the program, it should give us the sum of first 5 natural numbers, which is 15. This concludes today's video on the introduction to recursion. In future videos, I'll cover more advanced recursion concepts. Thank you for watching.